Thank you for introduction. My name is Koichi Sasada. Today I talk about this title, Object Lifetime Analysis with Ruby 2.1. By the way, this is my second time to stay in Taiwan, so I'm very happy to stay here. Thank you very much. And this slide is most important part of my presentation, so please remember this name. This presentation is supported by heroku company. So I want to introduce myself at first. My name is Koichi Sasada. This is a family name and this given name in kanji characters. I heard that there is no kanji, same kanji in China, Chinese. So this means bamboo, something bamboo. So. And I'm a happy person because I married with Yuki Tori-san in September. This is her picture. And I'm very happy because I can marry with Tori-san. And I also, I'm a developer of C-Ruby. Mainly making virtual machine, and recently I'm working on improving garbage collection performance. I'm working on heroku at the Matteam. I'm a full-time C-Ruby developer working in Japan, and I also board member, director of Ruby Association. So this slide is also advertisement presentation. Ruby Association is foundation to encourage Ruby development and communities. Chairman is Mats and located at Matsue City in Japan. We have many activities. For example, we do provide a programmer certification program. There is an English version, and also we do maintenance program, and also we held several events like Ruby World Conference, and also we do a Ruby Prize and grant project. So if you have any interest, please Google the name Ruby Association. We are welcome to your donation. And also, I'm a member of Heroku, so maybe you know about Heroku, but if you don't know Heroku, please visit this site. So this again and again. And Heroku is not only a path provider, but also supports many open source projects, includes Ruby. There are many talents in staff. And especially Heroku employs 3 Ruby Interpreter Core members, Matsumoto-san, Nobu, and me. So we name our group Matteam. Matteam working in Japan, but I'm in Tokyo and Nobu in Tochigi, and Matsumoto-san live in Shimane. So we communicate with Skype. Our mission is improve quality of next version of C-Ruby. So next version I say is Ruby 2.2 just now. Matsumoto-san decides specification of Ruby, and Nakada-san, Nobu fixed huge number of huge number of bugs, and I improved. My mission is improve the performance. So current target is Ruby 2.2, and maybe some of you are using Ruby 2.1, but Ruby 2.1 is stable and newest version for you, but our current target is Ruby 2.2. So I introduce some of Ruby 2.1 changes. Matsumoto-san, as Matsumoto-san keynote yesterday, he said he's introduced several features. And also we released a newest version of Ruby 2.1.1 at February. And version policy is changed from Ruby 2.1 yesterday, Matsumoto-san said. And also we introduced several syntaxes, required keyword parameter, rational number, literal, complex number, literal, and return of symbol as the def syntax. And also we introduced new features, some runtime features. And there are several performance improvements. So this is our my target, my job. So I want to introduce one thing to about garbage collection improvements. We introduced generational garbage collection. Generational garbage collection is concentrated on younger objects on garbage collection. So we can improve the performance, we can improve performance. So about 50 times faster. So this is execution time, and marking time is very, very fast after introducing the RGNGC. So the performance of the application we can improve 10%. And I will, so that is the achievement of Ruby 2.1. So next is, I want to introduce Ruby 2.2. As Matsumoto-san said, Ruby 2.2 will be released at this Christmas this year, but not announced officially. But Naruse-san, he is maybe he will be a maintainer of release manager of Ruby 2.2, and I need to change this point. We are here. So we are here, and we have several events. So we can improve performance and quality via these events. So rough schedule is that at September we will release preview 1, and November we will release preview 2. Maybe this is similar time to of RubyConf in United States. And also we will release release candidates. So after that, the release candidates, we only fix critical bugs and release 2.2 at this time. If no big trouble. There is no big features now. So if you have any requests or proposal, then please ask us. We can consider about that. Internal features, so we introduce a symbols garbage collector and some garbage collector improvements. And also I want to make more fast virtual machine, but not yet. So I go back to Japan. After I go back to Japan, I need to make more effort. Symbol GC is maybe some people want this feature. For example, this program creates n symbols, and symbols are not corrected, so it will be DOS attack. So it will be a security vulnerability. So we decide to make a symbol garbage collection. So it's only correct dynamically created symbols, but it is enough for security, we believe. So this feature is merged to the current trunk, so development version. So if you have any interest, then please try it. So today's main topic, I want to talk about the object lifetime. At first, so this is a common sense. If you create objects, then if you write this expression object.new, then allocate objects. And also this string literal also allocate new string objects. There is many object allocation in Ruby program. But we don't need to write the allocation code. Maybe you don't write object.free or something. So of course you know why it is. So garbage collection. So we have garbage collector in Ruby. By the way, this is ancient garbage collector. And the garbage collector was evolved. So recent garbage collector is here. And also, recent days, we have automatic garbage collector in our home. And also, Ruby has a smart garbage collector. Back to the Ruby. So, not Ruby. Human being lifetime is from birth to death. So this is a lifetime. It is easy to understand. And also the object creation, as the object created, then this is the birthday of this object. And object was created by garbage collector. So if nobody refers to this object, then object will be die. So this is a lifetime of objects. We can count the age of object with how many garbage collections surviving this object surviving how many objects we can count. So we say this age is the age at the dying is lifetime. So this is a simple definition of object lifetime. In this presentation, maybe some other person can define other lifetime of objects, but in this presentation, we use this definition. So how many garbage collection are passed on these objects? I defined the lifetime of objects, but it is important to improve the performance. So, for example, old objects slow down measure garbage collection. Many old objects slow down the measure GC. RGC or generational garbage collection reduce the garbage collection, most of garbage collection overhead. But if there is many old objects, then the performance will be down. And also, long life, or we can say old objects, can be unexpected memory leak. If you, so for example, create the long string, for example, the 1 megabyte or 100 megabytes string, and it is remain unexpectedly, then it will be memory leak. So reducing old objects makes Ruby program faster. So this is why I want to talk about this topic. So question is how to measure object lifetime and how to find old objects. So the answer is the allocation tracer gem. Recently, I made mainly for to present to talk about at RubyConf Taiwan. Allocation tracer enable to trace the object allocation and the allocation. So it has two features. The allocation tracer can show statistics data by line and show lifetime statistics table. I will show you the demo, so it is easy to understand. This feature is using new object free object internal hooks introduced from Ruby 2.1.0. So you need MRI Ruby 2.1 and later to use this allocation tracer. The first feature is show statistics data by each line. Each line we can collect the allocation count, old object count, and total object lifetime, and minimum and maximum lifetime, and total amount of memory usage. So I will show you the demo. I want to show you the demo, but there is no time to use the terminal, so I show this GitHub web page. This is a homepage of Allocation Tracer. So if you want to see the source code of Allocation Tracer, please refer this page. I wrote everything on this README, so please read them. This is first time to use Travis CI. Installation. So write allocation tracer in gem file and bundle install. It is very easy. Gem install is very easy. So for example, we can write a program in this block. So this is this method enabled to trace allocation and deallocation. So in this program, we repeat 50,000 times. So this program creates 3 strings for each iteration. So we can this program shows this result. So the line 6 allocates different result. Why not? Maybe it is bug. I will fix it after that. I'm not sure. So this is this line. This column is how many objects are located on this line, and how many old objects, and how many what's it? I have old objects and there is minimum age is 0 and 6 is maximum age. It refers the different data. Sorry, this is a documentation bugs. And you can also specify the type in this method. I add this line, so we can see the this program creates an array and string. hash and string, and range and strings. So this result shows the behavior of the result of this program. So we can see the different allocation information for each types. And also you can specify not only a you can only require this allocation tracer /trace library. Then after execution of this program, it will show the result of such results. This is tab separated table, so you can copy and paste to Excel, and you can find out how many objects are allocated by each lines. Back to the presentation. And also we can see the object lifetime for each types. So this is not by each line, but also the total the result of who objects, application execution. So with Excel, we can see the age of objects. So this is age. So this means that most of objects die immediately. Most of objects. And we can see the most of objects are string. String objects is 2/3, and quarter of objects are array. We can understand how many objects are allocated. And also, it is only for string. So this part of so most of string objects die immediately. We can see with this data. So that is what kind of data we can collect. And I want to also introduce example of usage of allocation tracer. So using byline statistics on RubyConf program, we can see this line consumes many memory. So 500 megabytes memory are allocated at this line. So I check this line. This line do this program. So this program this is a string, and string byte slice create string byte slice method create one string, and this string only used to calculate the length of this splitted slice of string, and it will be so this temporary object will be useless after that. So I make a new byte length method. It will not create any other temporary objects. So it will be fast. It needs this line does not create object anymore. So after that, we can understand so we can remove such a huge number of memory allocation. So we can tune the program of RDoc. And also memory consumption was reduced from this one to this one. So I prepare another topic, another tips of garbage collection. So I will also make a GC tracer, but there is no time, so I will skip this one. So we can collect the many data, and we can depict the many figure with graph with Excel, and we can do analysis. So I wrote everything in my slide of RubyConf Philippines at last March. So if you have any interest, please refer this presentation. So summary of this talk. So the most important part is allocation tracer gem will help your optimization for your application. If you have any trouble on memory consumption, please try it. Thank you very much.
Does anyone have a question for Mr. Sasada? Please raise your hand. Oh, wait.
Yes. So this feature is using only MRI, so only MRI supports this feature.
Is that something you would run in a production environment and then gather statistics, or something you just run sort of on the desktop, and like, what's the performance impact?
Huge.
Huh?
Huge impact. So slow down.
Slow down. Okay,
Yeah.
so not production. Okay.
So I recommend you use it on development mode, development environment.
Is Heroku going to have some hooks to that so that we can improve that, or?
If you have help.
This is a little bit unrelated to this, but what's the status of the tail call optimization, and is it planned to come back to be enabled, the tail call optimization?
Tail call optimization?
Yes, is it still, so it's in Ruby, but it's disabled. Are there still plans to enable that, and what are the main blockers for that?
Actually, we have tail call optimization option, but it's not enabled on default because of the compatibility issue. So tail call optimization eliminates the backtrace. It will be a problem for some application, some kind of application. So it is why we cannot enable it default. But there is several proposals about that, so we can consider about that.
Thank you.
Last question. Anybody else? Okay, thanks to you, Mr. Sasada Koichi.
Thank you very much.